when evaluating a definite integral, for example, like this, the integral from a to b from f of x dx, we need to ... if ... first. When evaluating a definite integral, the integral from a to b from f of x dx, we always need to
determine if it's continuous.
Yes, check, very good. Check if f of x is continuous on closed interval a comma b. This is our first step every time, because we may get a question like this that will go around in circles. We'll put it in the graphing calculator. We will get error. And what is the error about? Okay, it means that that's the first thing we need to do. Like with the limit, we plug it in to see what the situation is. Same thing here. We have to check that this function is continuous. Otherwise, FTC is not applicable if it's not continuous. From left to right midpoint rules of approximation or approximating areas, which one is the best? None of them is perfect, but from these three, which one is the best? Will give us the best approximation.
Midpoint?
Yes. Thank you. For any number of subintervals. When evaluating an indefinite integral, the final answer must be given in the blah, blah, blah variable. When evaluating or determining an indefinite integral, which is a family of functions, not a number, the final answer must be given in the ... variable.
Original.
Thank you. Always, we have to go back and plug it in and remove the substitution. For indefinite, we can or we cannot copy the limits of integration for x to the integral in y or any variable. So I have the integral from f of x dx from a to b, and I go to an integral in y. Can I copy these limits here?
No.
No. We cannot ever copy the limits of integration for x to the limits of integration to the integral in y. We have to determine them. This will create a number here, and this will give us a different number here. If the interval is symmetric from negative a to a, we must check if is and then proceed. If the interval is symmetric from negative a to a, negative 5 to 5, negative 2 to 2, we must first check if
the function is odd.
Yes, the f of x is odd or even. Okay, and then proceed. If it's not, it's not. It's okay. Then I cannot conclude. I would just have to proceed accordingly. Okay, last two. After we decide on a substitution, so for example, I said, let's say we are using y or u, whatever letter you want, it doesn't matter. We must calculate what next, which is the... So we said, okay, let y be whatever. What do I have to calculate or determine next?
The derivative with respect to the variable.
Careful, not the derivative. So if the new function we created is y, what do I have to find? Not the derivative.
dy.
Thank you. Without dy, I cannot proceed. What is this called? And this is not the derivative. What is it called? Very important name.
The differential.
Differential of y. Awesome. A substitution is expected to make the integral to calculate. Otherwise, what's the point?
Easier.
If it doesn't, I'm on the wrong track. Awesome. The floor is open for any question you may have, or questions, or anything you need help with, anything. So one question was, before everyone came in, I asked that question. Is the first homework submitted? I did not get the chance to look. Is the first homework submitted for today?
Yes.
So there is no need for an extension for the first homework. I extended the second one till Monday. And if you already submitted, you can submit again. It's not a problem. It accepts as many submissions as you want. Okay, any questions? I'm ready for your questions. Anything you need help with? Anything?
I have some questions from 5.3 in WebAssign.
Yes, anything.
Um,
I'll give you permission. You have permission to share your screen if you want, or just tell us what it is and I'll write it.
yeah, I'll tell you what it is. So it's number 13 in 5.3. It's the integral from 1 to 2 of v to the 4th plus 4v to the 8th over v to the 5th dv.
Perfect. So I'm trying to open the book and it's frozen. Did you have this? Oh, okay, it just came up. Okay, perfect. I just want to have this open in the background so it's ready. Okay, perfect. Okay, so remember what we did when we differentiated something like this, and you can say, what's the point of, yeah. So let's look at this function. What did we do in the past? Forget about the integral right now. We're looking at the function. What did we do in the past with something like this? Anyone remembers?
Simplify.
Yes. How?
We would split it since it's a single denominator. So
There is one term in the denominator. That's the easiest to do. Yes, absolutely. That's what we did. So the function can be rewritten as v to the 4th over v to the 5th, which is 1 over v, plus 4, v to the 8th over v to the 5th, which is v to the 3rd. Copy the base, not the vase, copy the base and subtract the exponents. So 4 minus 5 is 1 in the denominator, and 8 and 5 is 3 in the numerator. At this point, so basically what we looked at so far in this class, and we will not look beyond, we really have two techniques. That's not what I meant to write. Two techniques of integration. This one is just direct. Direct. Number one, direct. There is nothing I need to do, right? So I have natural log of the absolute value of v plus 4, v to the 4th over 4 from 1 to 2. That was direct. And number two is basically substitution. This problem does not need a substitution because I was able to determine the antiderivative directly with no headache. So now I have to apply fundamental theorem of calculus, part 2, plug in 2. There is no need to put the absolute value on 2. It's very clear. Simplify here. 2 to the 4th is 16, minus. When I plug in 1, I get 0, minus. When I plug in 1, I get minus 1. So then the final answer will be natural log 2 plus 15. It's a definite integral. I cannot check. I can check with a calculator, but I cannot check by hand. But for every indefinite integral, and I'm going to go back to any of these, choose any indefinite integral you want to work on, because I want to show you how to check. We only looked at 2 indefinite, so choose one, whichever you prefer, because I want to show you how you check your answer. Let's start with number 17. Don't forget, I did not forget that you have other questions. Any questions on this problem for now?
No,
Where
that
did
was
the
good.
minus 1 come from?
Say that again.
Sorry, where did the minus 1 come from?
Very good.
Because it's v.
Hold on. So f of b minus f of a, where a, this is b and this is a. I plug in 2. Natural log 2 plus 2 to the 16th. I mean 2 to the 4th, which is 16th. Minus, when I plug in 1, I get 0. When I plug in 1, I get 1, but it's minus.
Okay.
Better?
Mhm.
Perfect. I think somebody else had a question.
Oh, no, I was just, I asked the question and I didn't simplify, and that's
Okay. Is this okay, everyone?
Yes.
Anyone else has questions on this problem? Okay, problem 17 that we worked on last time was the integral from cosine theta over 1 plus sine theta d theta. And our result was natural log of the absolute value of 1 plus sine theta plus a constant c, of course. So the question here, what I wanted to show you is this true? Is this correct? No, I don't need anyone to tell me whether it is or not. All I have to do is differentiate both sides. And I have to get the exact same thing. If I don't get the same thing, then I'll say, oops, it makes no sense. I go back to the drawing board. So when I differentiate this side, we already discussed this. When we differentiate an integral, these go away. So the left-hand side is cosine theta over 1 plus sine theta. Done, and nothing else. Now here, when I differentiate natural log of 1 plus sine theta, I have 1 over 1 plus sine theta times the inner function prime, which is cosine theta, plus c prime, which is 0. So checking whether your answer is correct on indefinite integrals is a piece of cake. Checking here, I have no way other than plugging in the graphing calculator. There is no way I can check. I can do it again, step by step. I can check my step, the step that I can 100% be sure, right? But here, it's 100%. I differentiate the left-hand side, and I got this. I differentiate the right-hand side, and I got this, and they're identical. So then I know that this is indeed correct. Natural log of the absolute value of 1 plus sine theta plus a constant c. Good. So let me keep my pages in order. Okay, yes. Next question. Anything else you need help with? Anything?
So another one from 5.3, and I
Yes.
think really all I'm looking for is like what the first step should be. So it's evaluate the integral from 1 to 4 of 4 plus x squared over the square root of x dx.
Identical situation.
split it.
It's one term.
simplify.
One
Yeah.
term.
Okay.
So this will be the integral from 1 to 4. 4 over this will be 4 times x to negative 1/2 plus this over this will be x to 2 minus 1/2, 3/2 dx.
Okay. Thank you.
Thank you. Next question. Anything else you need help with? If not, I will go back to 66 because I want to show that option. Anything else you need help with, please? Anything else? Other questions? Okay. So I wanted to go back here just for a second to this one. The integral from, it was 66. And this was the integral from 0 to 1, e to the x over 1 plus e to 2x dx. And last time we said, okay, what if we use u 1 plus e to 2x? And then I said there is an easier way. But I just want to show what happens here. So after we establish the substitution, as we know, we have to find du. But when you find du, you will get e to 2x times the inner function prime, so 2e to 2x dx. And this is a problem. So we have dx, but we do not have e to 2x at the top. We only have e to x. I know that the denominator can be replaced by u, so that's okay. But I need to determine this e to the x. dx, in this case, I have to solve this equation for dx. So then dx will be du over 2e to 2x. So we will replace this, but I can put x in dx. So this piece will be du over 2e to 2x. But I have to take it from here because I can't have x and u in the same integral. So this e to 2x will be replaced by u minus 1. Okay, so far it's okay. I have 2 u minus 1. But now I have to do something with this. And what can I do? I have to take the square root to get e to the x as the square root of u minus 1. And this becomes not user-friendly at all. So from here, the integral will look like this. Careful, 0 is 1 plus 1. 1 is 1 plus e squared. So look how the integral looks at this moment. Do you want to work with this? I hope somebody is watching. No. No. So that's why it's okay to try other things. But if you get to something like this, they say, nah. Well, let me think again and come up with something else. Good. Thank you for listening. Next question, anything else? I would like to practice more indefinite integrals. Okay, anyone else, please? Anyone? Any questions? Is everyone with me, please? Is that a yes?
I have a question from homework too, but since we pushed it, I'll wait till Monday.
We can look at something similar. Can you find something similar? Which section was it from?
Let me find it again.
Was it from 5.5?
I think so.
Okay, we are on 5.5 right now, and let's choose something similar.
Okay. So the homework question was 76.
So let's take a look at 76. Okay, so let's do 76 in class. And you don't have to do it. 0 to 2, x minus 1, e to x minus 1 squared dx. Perfect. Okay, so I have to change the position here a little bit because the other camera is a little bit off. Okay, so what do you think is the problem here? By problem, I'm saying, okay, let's use a substitution for it. We had a similar situation. I specifically wanted to show something like that. So e to the x, or there was another one, this one. So this is an identical situation. I wouldn't say identical, but very similar. That's why I was hoping that everyone will look at this first. Okay, so what do you think is the problem, so to speak?
So I made u x minus 1.
That's not going to work.
No, it didn't.
So why don't you take the whole thing? Because that's what we did with the other example.
When I took the differential, it looked like it was making it harder, so I stopped.
No, the problem is the whole thing. It's a function inside a function. That's the problem.
Right.
So then du will be 2x minus 1 to the 2 minus 1 times the inner function prime times dx. And it's right there.
Okay.
The 2, the x minus 1, and the dx. They're all there. So
Professor,
then,
I had a question about the same problem.
yes.
So I got to that step, but when I plugged in for the new integral, I got an interval of 1 to 1, and I didn't know what to go from there.
Then the answer is 0.
Oh, okay, yeah, that's what I put. So
Yeah.
I
So
wasn't sure.
because we know a property from a to a from f of x dx, the answer is 0. This is one of the properties of the definite integral.
All right,
It's
thank
possible, very possible. So I have 1/2 in front. So I have 2. So 2 and x minus 1 and dx, they're all in du. And this is e to u. Now, when x is 0, 0 minus 1 is -1. -1 squared is indeed 1. When x is 2, 2 minus 1 is 1. Yep, so there is no discussion. The answer is 0. And remember, for the definite integrals, very good question, you can always check with a graphing calculator, math, and I think it's 9. Okay, yes. So you have from 0 to 2, you'll see. But the difficulty part here is how you enter it. Because if you don't enter it correctly, then it may frustrate you because you can see what the problem is or why the answer is one thing and you got something else and who knows what. So be very careful how you enter. So when I click enter, I have to get 0. If I don't get 0, then I'll say, oh, whoops, I have to go back to the drawing board. Good. Other questions? Anything else has other questions?